Hi everyone, I'm happy to be here today. I'm Yshay, I'm the CTO of Livecycle, and today I'm going to talk about self-contained development environment. I'm going to start this presentation by sharing an experience I had a few years ago. So back then I worked at a company called Soluto, and I led the development of an open source solution for feature flagging and remote configuration. Since the solution was an open source solution, we wanted other developers in the company to contribute code to it and make it better and add their own features. In order to encourage them, we've organized an company-wide hackathon, and because the project was called Tweak, we called it a Tweakathon. And the team was super excited. We created like an organized backlog. We added some documentation in rough areas. We print some shirts and have like swag of Tweak. And well, the event started, and well, at the end, it didn't work that well. The problem was that most developers in the company were struggling to run and build and run the project. I mean, the bootstrapping was so difficult, and many of them didn't even get to the part that they are starting to develop features. They just start trying to make everything like work together. The project was complex, and the Tweak team was going from one station to other station and helping developers install missing dependencies or having like the right configuration. And at the end, we had some few features that were added, but the experience for most developers wasn't that good. And to put it simply, the onboarding was way too difficult for an hackathon. And that's the topic I'm going to talk about today, how we can make it much more easier to run a project and do like the onboarding and make sure that developers always have like great experience when working on this project. New and old developers alike. Before we start we start to deep dive into this session, I'll tell a bit about myself. I'm Yshay, I'm the CTO and co-founder of Livecycle. I'm a full-stack developer. I'm passionate about cloud development, backend architecture, functional programming. I'm the creator and maintainer of Tweak, an open source cloud-native feature management solution that I mentioned. And I really care about simplicity, consistency, and elegance in code. About Livecycle, we are building the next generation of collaboration tools for development teams. It's based on the idea of continuous playground environment, and it's designed to bridge the gap between coders and non-coders. And you are more than welcome to check it out. You can try it on livecycle.io. So let's start by describing how does it feel like when we start working on a new complex code base. So first of all, we are trying to build and run it. But in many cases, we don't have the right operation system, or we have missing or conflicting SDK or programming language runtimes. It can be like Python 2 or Python 3, for example. We have package managers that throw, let's say, random errors. I mean, they're not necessarily random, but they certainly feel that way. And then, well, we saw that it didn't work that well. We are trying to read the README. And then in the README, it said that we need to run some magic scripts, maybe change the host file if it's like a really complex project. We need to install tools and dependencies on the environment, such as databases or something like that. Maybe install root CA in like, I mean, I hope you don't have this problem, but if it, I mean, that's certainly not fun. And okay, we build it and we run it, but now we try to develop. And in many cases, the debugging doesn't work, the IDE doesn't like have problem like attaching. In many cases, we have like problem with autocomplete or dependencies. Code watch and build doesn't work, and we need to install like Watch or other tool for better watching. Auto model reloading, if we are working on a front-end app, doesn't work because of, I don't know, WebSocket issues or something. Problem with external dependencies, course, you name it. And that's not the worst. Then we get to like integration test. which in many cases simply just are not running. Especially if you have like something that is depend on web driver test or UI test. So it can be difficult. And the worst thing about it is that all this setup and we need to do it like over and over again after a few months if we started to work on a different project. So if we like come back to the project, there's a good chance that we need to do like this whole setup again. Maybe because the project got updated, or maybe we installed other dependencies that are conflicting, and that's definitely not fun. So why is it so difficult? So I mentioned some of the problem, but it can be like, we have lots of fragmentation in operation system, in SDKs, in runtimes. In many cases, it works on my machine and I don't worry about it anymore. Like I will prefer like replace machine only if my machine got burned or something. I mean, it works, I'm not touching it. And that's the problem when we're trying to set up like a new machine. There's a vast amount of different tool chains, IDE, extensions. Our development workflows today are much more difficult to set up and they can break, like debugging, watching, building, auto reloading, maybe mounts. We are not just doing like build and run anymore. We want to have like good tooling. The developer machines are also like polluted and overloaded with tools. And beside that, like environment and tools tend to change rapidly in active repositories. And so at the end, we have like lots of frustration and we waste tons of time. So how can we make it better? So what's the dream? So the way I see it, the dream is development environments that are consistent. We have the same predictable experience. They are reproducible, so I can destroy and rebuild them. I don't need to care about that I managed to make it working. They are isolated, so they are not get affected by other development environment that I want by other project that I'm working on. They are self-contained, so all the dependencies and tools that needed for development are defined and packaged inside the environment. It can be like a database or an SDK or something like that. So if lots of the stuff sound familiar to you, is because lots of this stuff has been said about containers and lots of these properties that I mentioned. And 2.5 years ago, VS Code released a really amazing feature, in my opinion, that allow you to work on the VS Code. VS Code is one of the most popular IDE. I'm sure most of you are probably using it according to surveys. But they introduced a new amazing feature that allow us to have our own local IDE running on our computer, but the environment itself is running inside a container. So in terms of experience, we still have the native UI that is running. It's not like a full remote solution, but the VS Code instead, all the extensions and the language server and the debugging and the terminal and everything is running inside the container and not inside our local installation of VS Code inside our host machine. So this allows us to have a great developer experience in a very well-defined and consistent development environment. I'm going to show a demo. How does it look like? All the examples and slides are available on GitHub. All the tools used in this presentation are open source and free to use project. I'm not selling here anything. Most examples here are, I will say that they are not bulletproof completely. And they are using some tools that can be considered experimental, but they work and they work well. You can easily reproduce them. And in this example, I'm going to go through several projects and show how we can use this amazing new feature and how we can configure our project better to have this kind of experience. So I'll try with a simple example. That's a CLI tool that take an image and turn it into ASCII art. It's an open source project. The project is written in Go. It's written in an old version of Go before we had Go models. So it requires some tweaking to make it work if I was running it locally. So let's open our IDE. And this is a regular VS Code, but you can see that it's working. Here we see on the green light that it's written like dev container Go. And what does it mean? So to showcase it, if I go and take an open terminal here, and see if I have like the Go CLI or tool, we see that I don't have them. They are not installed on my computer, but here I have them. Why? Because this terminal is not running directly on my host machine, it's running inside a dev container. But I still have like the same experience of a regular terminal, which is amazing. And it's not just the terminal, it's like everything in the editor. So how does this magic happen? Simply we have a dev container folder with a dev container JSON file. Here we define what we want to have the configuration for this development container. We can define what the Docker file that is used to build this environment. We can say some settings for plugins. For example, I define some settings for the Go extension. I also can define what extension in the IDE I want. So in this case, like the dev container have dedicated extension of VS Code. It doesn't have like my whole array of extension. And I have here other stuff that I'm doing. Because this project is an old project, I need to do like a symlink between the folder and the working folder and the Golang path convention that they use in the past for modules. But the good thing is that I don't need to worry about it because it was done for me. So if I look here on the Docker file that is used to build a container, we can see that I'm using a base Ubuntu image, I'm installing Go, I'm setting an environment variable to not use Go model, I'm installing other tools that are relevant for Go, such as DEP, is like an old dependency management manager that this project uses. I'm installing, I'm using the Zash shell, and I'm installing plugins for the shell. So if I'm going to use like a Git, so we can see that we have like autocomplete for Git and also for Go, because here we define the plugin of Git and Go. Amazing. So let's try to run this project. I'm going to do like Go run, image ASCII Go, and we can see that it need to have like a file using the -f flag, and I'm going to try to run this file, and it won't work because it's like a URL and this project doesn't support it. If I go to the code, we can see what we need to add for supporting URL. Basically, it's like adding the kind of logic here in the open image file. You can see, first of all, that I have like full autocomplete, highlighting, I mean, everything just works. And I'm going to check out the branch that I have this implementation. We can see that I have like everything like from the source control perspective, everything simply just work inside this dev container. And again, everyone that will open this project is going to have the same experience I'm having now. No need to do any setup at all. Okay, so I've added I did a checked the branch, and we can see that in the new branch, we have a code that download the image if it starts with HTTPS or HTTP. Let's try it. Okay, so that's like my profile image in ASCII art. Let's have the Python logo or Docker. And again, it was very simple. And if I didn't have the dev container, I can like waste hours making it like work and have like a good developer experience. You can see also that we have some errors here. And basically, if I was trying to run the test, they would fail because there are missing dependencies in the project. And if I'm going to run the dependency manager here that is also installed inside the dev container, I'm going to run the test and everything work properly. And I'm not sure why it's still red. It's like missing. So after the insertion, it actually should work properly. Maybe I'll just do go build. But you can see that the tests are working and the application is running. I think that the mock dependency, for some reason, VS Code didn't identify it, that it was fixed. But if I reload the ID, it will probably work. Okay, so that was the first example, and I want you to take notice on what we saw here. First of all, we saw that we are running inside a development container. So the development container has integration with the SCM. That's why I can do like git commands and check out a different branch. We have remote code editing, so I can like edit directly, and we have a remote terminal. In addition, we saw some configuration of the environment. So we set out the runtime, we set environment variable and path, we configured our shell, and we define extension for VS Code to use. Okay, let's continue to our next example. And it's a Python application. So again, it's a Python conference, so it kind of makes sense. Here we have a simple Flask application to send email based on SendGrid example. I mean, a simple Flask application to send email. It is based on the SendGrid example. So again, all these projects are open source. You can try them. Here we have a new challenges. We need to run and interact with a server. And we need to manage secrets, such as the Flask secret, the SendGrid secret, and we need to have a good debugging experience. So let's try that. That is the project of my Python project, the simple email sender example. We can see the dev container here. Here, for example, I won't have like Go or Node or the other stuff I had in the previous dev container. I just have like a Python 3.9. Here in the dev container, we can see the definition. We can see the settings that I want to add to the Python extension, the extension I want to use. And I'm going to show there's the Docker file here, and in the Docker file you can see that I'm installing another tool called SOPs. So SOPs is a tool that's designed for encrypting and decrypting secrets. I'll show you how I'm going to use it. So basically here I have the configuration of SendGrid in a file that is also part in the source control, but it's encrypted. I mean, no one can read it. It's encrypted with a GPG key in this case. And to showcase how I'm going to use this file, I'm going to show a different file, for example, that's called example encrypt. That here we also have a secret, but it's in the secret file we had like the SendGrid API key and the mail default sender. This is like metadata. But here we have some secret number. So let's try to decode it. I'm going to use subcli. Let's do -d. And you can see that I have like the secret number here is 30. I can put it like in a file, and the other file that is decrypted is not going to get a check-in inside the source control. And you can see that I can easily edit it as well. So if I'll do sops edit, I can change here the number. And if I'll run the decrypt again, we can see that it's the right, a different number, it's 40. And we can see that in the source control, that this file is also like changed. So if we look in the init file, we can see that the first thing we are doing, we are decrypting the secrets, encrypt JSON, and put it in a .env file. that Flask can use. And then we install all the requirement. So let's run the init. Okay. Now let's try to run the application. So the application is running. The reason that it's running this way is because we have a launch JSON configuration that defines how the app is going to run. It basically created automatically the moment you run it the first time. In this case, it's also like a source control. So it only, there's no need to create it like every time. So we have the application. We'll see that it's running on port 5001. And you can see that it's running on the localhost of the development container, but we want to access it on my machine. So how can we do it? So first of all, I'm going to show you that somehow magically it works. So that the application, I can send a test email. Oh, no need for the breakpoint yet. Spoiler. Let's go back. So I sent an email and it just now, so it works. But the thing is, why does it work? Here I'm the local host on my machine. And the reason is because VS Code do a port forwarding automatically. So we see that port 5001 on the container is forwarded to my local address on port 5001. So that's simple, and I can forward any port that I want. From here, I can also open it inside a VS Code, like in a browser here. And I'm going to, let's send it again. And I'm going to put a breakpoint and decide before, but basically, again, it simply work. I have like the full experience, although I'm not running on my machine. The ID is running locally, but the container is running on like a different machine, and we still see like we have a great experience. We can see the watch variable, we can debug, we can do breakpoint, we can do like everything, and it simply work. I don't need to do like any setup for that. I'm just opening the container. I'm just opening the application. VS Code will recognize the dev container. It will run inside it will run the application inside the container, and it will have great experience. Okay, so that was another challenge. If we'll go for what we saw here, so basically we saw secret encryption. We use Mozilla stops for encrypting the secrets. I'm using it with a GPG key, but actually it's much more powerful. It can also connect to other encryption as a service solutions, such as KMS of AWS or HashiCorp Key Vault. The metadata, such as the keys, are saved unencrypted, so it makes it very easy to do diffing and check history, as we saw in the Git diff. This practice is not actually used for dev environment all the time. It's actually popular in GitOps context when deploying stuff to production that needs secrets. So there are other solutions as well, such as Git Secret, GitCrypt, and other. The ID setting, we saw that I'm using a launch JSON for configuring the launch of the project, and I'm doing like port forwarding to forward port on the localhost. But again, that was pretty straightforward. The next project I'm going to show, it's like a step up in like complexity, and it's a personal project. So, it's Tweak, the open source feature flag management solution that we used in that hackathon. So in Tweak, we have lots of challenges. We have several microservices, several databases, messaging system, cross-service communication, different languages in each one of the microservices. The architecture looks something like that, and it's very complex in terms of like dependencies, kind of services, can be really challenging. And to solve it, I'm going to show how we are going to use not just Dev Container, but also Docker Compose and Tilt. So let's see the example here. So that's the Dev Container of Tweak. we can see that we are mounting here a volume for Docker in Docker. I'm installing the extension of Docker. Okay, so first of all, you can see that I have Docker inside it. So, and it's like a nested Docker. So we'll see that first of all. We'll see that how we can make it happen in like the Docker file. So my extension include Docker, so I can see the containers that are running. It include the .NET because one of the projects is in C#. It include the Golang, and it also include the prettier for like formatting of JavaScript. The post create command install like all the dependencies, like doing like npm and a .NET CLI installation, so we can see it here. .NET restore, run all yarn and all the other stuff. And the Docker file itself, that's where it gets interesting. So we have some code here that designed to run Docker in Docker. Everything here, it's actually taken from VS Code examples. We install CLI extension plugins for Docker, Git, Golang, and .NET. We're installing .NET. We're installing Golang. We're installing Node.js and Yarn. And we're installing Tilt. So basically, we have all the things that we need to run, and I'll talk a bit about Tilt. First of all, we can see that we have all the services. I can debug them. I can have like good experience for every kind of file because I installed all the right extension in place. But when we are running them, we want to run like the full installation of Tweak with all the dependencies and complexity. And for that, we have a Docker Compose file. So Docker Compose file is, maybe many of you know it, is a file that's designed to describe a setup of several containers that are running. And each container, what are the environment variables? It can also define what's the build context to how to build them, or where do we get the Docker file for building them. So here I have the Docker Compose files, and the important Docker Compose one is the one called Tilt YAML. It's also a Docker Compose file that includes like all the services that we are running, all the environment variables, all the configuration. And the reason we are using Tilt, so Docker Compose allows us to run all this application, but Tilt allows us to have like a good development feedback loop. So every time we change a code, it's going to rebuild the image or try to do a live update. So for most of the services, we are simply, on every code change, we are going to rebuild the image and then run it. But for the editor, we are going to do auth model reloading. So let's run Tilt. We're using the command tilt up. It's the same as Docker Compose app. And here we have like the UI of Tilt. Let's see it running. And we can see that it's run at port 10350. And this port is also forwarded here. So we can see here all the services of Tweak, the API, and every service we can see the log for it, so it's very convenient. We can see here the application running on port 8081. And I'm going to show that that's like the editor, the UI of Tweak. I'm going to show that we can easily do a code change. So let's go to a login page. Let's open it here as well. And instead of welcome to, I'll say Python Conf42. So I changed it, and it was changed like with auth code reloading without refreshing. I can change also, I think the login message here, welcome message span. So let's change it as well. We put something like that. will be more welcoming. And it simply works, and we have like a great developer experience. And again, it was something that was very difficult to developers when they try to work on this project on Twig. Just running it was difficult. And now if they are opening this project, they can easily run it, debug it, do some changes in the UI and get auto-loading experience, do changing in the services and get image rebuilding and rerunning it, and everything simply work. And I mean, it's really amazing. I wish we had this kind of technology and capabilities like it was 6 years ago, I think, or 5 years ago. So it's really amazing. Okay, so the last example I'm going to show. So let's talk a bit about this example. We saw nested containers. We are using the approach of Docker and Docker. There's also an approach that's called Docker from Docker, which we want the host Docker connection, but I think Docker and Docker is much more stable. And if it works well in terms of performance, you should consider using it. We saw watching and rebuilding on every code change, remote debugging. I mean, we can have like hot code reloading if possible. And things can get slower, but it's definitely worth it. Also in Twig, we mock cloud dependencies. So the reason the application works is because we have the Docker images of database. So we have image of Redis there that is running, image of NATS. We also use wire compatible solution to other dependencies. So Twig use Amazon S3, but here we use Minio, which is S3 compatible, and we use OIDC, OpenID Connect mock server, which is compatible with like Google SSO. So that's the reason we can have like great local development experience. Last project I'm going to show, and I'll try to make it short, is a project called Cost Model. It's a tool to manage Kubernetes cost. And the reason it's interesting because the Kubernetes deployments can really be complex. There's a new challenge. We need a Kubernetes server. We need a metric server, and we need Prometheus, which is a time series database. And I mean, Kubernetes, if you are familiar and try to use it, it's a container orchestration solution, and it's like a full platform, and it can be very difficult to use. And running local development of Kubernetes today is already difficult. We have a fragmentation of different Kubernetes distribution, and each one of them have like different changes in how you use them. Versioning is difficult, upgrading is difficult. So using dev container, maybe we use a single Kubernetes distro and version, and it can make the life much more easy. So I'm going to show the example of using, in this project we are going to use a project called K3D and K3S. So let me just turn off the tilt here. So that's the Kubernetes cost model. It's also used Docker in Docker. We have the extension of VS Code YAML for editing Kubernetes manifest. We have Kubernetes tools, so we can see like the cluster I have. We have Golang because the product is in Go. We can see that I have a Kubernetes cluster that is running. And if we look at the Docker file, we see that we are installing Docker in Docker. We're installing autocomplete for kubectl. We're installing K3D, which is the tool that's designed to create Kubernetes cluster, K3S clusters. We are installing Helm, which is a package manager for Kubernetes, Golang, Node.js, and again, Tilt. So if we look at the init script that we have here, so we are running all the dependencies, but the interesting thing is that we are creating a Kubernetes cluster. And also we can create a Kubernetes cluster with registry, so we can deploy, build and push images and deploy to there. Also, we are adding we are applying the manifest there in the dev container, which is the installation of Prometheus. So Prometheus is a time series database, and here we use an Helm chart of Prometheus, then we have the definition here. Again, everything is happening declaratively. So when I'm running this project, everything is going to run, and I will have a good experience that I have a Kubernetes cluster running locally. And also using tilt again, if I'll do tilt up, basically tilt connects the image that I'm building locally with the Kubernetes cluster that is running inside the dev container. So we can see again, let's do a refresh here. And we can see that we have the cost model, which is the API that calculates the cost, and the UI, which is the UI application. If we look at the tilt file, we can see that we have Docker build of the cost model. We are pushing it by doing the Kubernetes resource and loading the Kubernetes YAMLs that we have here. And we have a local resource, which is the UI that is running. And again, that is running with auto reloading and all the things that are necessary. So the application server, we can see it here, and we see that it works. And the UI, we can see here. And the interesting thing about it, that if you look on the, it's an open source solution. So if you look at the contributing file, you can see that in many cases it can be very complex to run this application. You have separate steps for building and running. You need to do a port forwarding. And in this case, like everything is just happening by running the application. So that's one example of how we can create a so much better development experience. The other thing I'm going to show in this example that I can create this cluster. Called the cost model, I think. Let's see. Cube cost. Okay, so let's delete it. And let's run the init function again. And I'll open it here additional terminal. And we can see that we have Kubernetes running here. So it's still not running. Let's see. Okay, we have a cluster. If I use context, so let's open the additional terminal. Oh, no need to open it. Okay. So let's do kget node. We can see that we have a cluster like in, again, a few seconds. And if we'll do like get pods, all namespaces, we see that all the setup of like setting Prometheus and the metric server, everything is like running, traffic is the reverse proxy, but basically it's done like everything automatically. And in less than a minute, we have a working environment of Kubernetes that include all the dependencies we need for running this application that actually have very complex dependencies. So again, it's an example of how dev container is actually can be used in so many scenarios of developing application, even if these applications are very complex. Okay, so that was the last demo. So we are using, for running Kubernetes in the dev container, we are using K3D, which is a Kubernetes, it's based on Kubernetes, K3S, which is a minimal Kubernetes distribution, and we run it in Docker. We use Helm for installing the chart, as we saw with Prometheus, then the Helm controller do it like declaratively. And we use Tilt for facilitating build, pushing, running, and updating of images. To put it simply, what we saw in this example, so we have the Docker host that contain the dev container, that contain the IDE and Tilt, and inside the Tilt and the IDE are connected to Docker and Docker, which have a registry and a Kubernetes node that inside have a containerd that run the application. So it's like a very nested thing, but the good thing is that it's all like automatically, And to put it visually, it's something like this. Okay, so that was the last demo, as I mentioned. I think that this example showed that containerized development environment are something truly amazing. The good thing about them that they are also source controlled, so they correspond to the application code, so it can be easy to run like old version of the application. The developer machines stay clean. We can scale well to multiple environments without conflicts. As you see, I run so many environments and everything like works smoothly. They can run locally or remotely, which is, again, very convenient if you want a much more powerful machine. Our setup at Livecycle, we actually have like tens of microservices, even more today. In Golang and TypeScript, we have a frontend without model loading. We have our own Kubernetes controllers and custom resources, lots of external dependencies, full-blown CI system, GraphQL engine. I mean, lots of stuff is happening there, as well as CLIs and SDKs. And even though the setup is so complex, the time to build all this setup, tear down and build it completely from scratch is less than 50 minutes. The time to build run test code changes is less than 10 seconds. Even less for UI changes. The time to onboard new developers so far is less than 3 hours, and that includes like setting the Docker and creating provisioning a machine on AWS because we are working remotely. Time to introduce a new tool to the project is less than 5 minutes if needed. There are no work on my machine occurrence. There's no strain on developer machines. Secrets are encrypted in the repository, so developers need less to deal with them less. They don't need to like copy .env file from place to place and using Slack secret to send them or something like that. We are using data seeding, so developers have initial data to work with. And the team our setup work on both Apple Silicon devices and Intel Macs. So it's really nice to see that it simply works. In the future, I hope to optimize it more, to have like shared build cache, to have snapshots, so to reduce that 15 minutes in like the first time, and maybe like using a better cloud provider optimized machine for instead of AWS, something that is much more cost effective. There are some drawbacks here. Creating the initial setup can take some time. Lots of the tools are bleeding edge. There's additional code to manage, like the code of the environment. I think the big problem is that dev environments are not standardized yet, so we have coupling to VS Code, Docker, Git, and Linux. Docker, Git, and Linux, I don't think it's like that bad, but VS Code is actually we don't want to dictate the IDE to use. And there's also like some performance issues. Do we have alternative to VS Code when using dev containers? So it's possible to use terminal-based code editors. Gitpod and FIA have similar features as well with a Gitpod YAML file. But the one thing I'm most excited about is that JetBrains are having like good support for that, both in like their Gateway project and Gateway and Spaces, and in Fleet, which is their new IDE. So yeah, I think that in the future, we have like a more alternative. The experience in VS Code is amazing, but not everyone wants to. It's not the favorite editor of everyone. I think that putting like the development environment configuration in the repository is part of a larger trend to put like more stuff in there. We can see it with documentation, with linting configuration, with we can see it with like a test or security test and design systems, infrastructure as code, notebooks, and other stuff as well. And the way we see it, like in the future, every repository will be self-contained. All the code tools and knowledge and definition related to that project will reside in the repository. Everything will be source controlled with history. The code will be so much more accessible. We are lowering the barrier of entry because everyone doesn't need to know stuff externally to the repository or start to do like a research on how to make everything works. The applications are portable. It's really amazing that if I'm creating like a project, I can control the developer experience of the users that are going to use my project. And I can make sure that they have good experience. And these kind of technologies, I think that we are seeing emerging tools ecosystem. Cloud IDEs, dedicated PR environment that is like the PR environment is something that we actually do in Livecycle in our product. And also we see emerging ecosystem in everything related to GitOps, that we have like a repository and we want to publish it, publish the application. I've shown lots of tools here. Here is a small cheat sheet of every like challenge, what's the solution, and tools for examples. Some of the examples here relate to stuff I didn't show in a concrete example, but they are very similar. There are challenges that you can tackle if you are trying to use dev containers. And thank you. Everything is on my repository, and I also post links on my Twitter account. It was fun and very interesting, and thank you for your time.